Hello, I am back just checking in for a little bit of information in our weather unit. I wanted to touch on this item is called a station model. You have a document in Moodle titled Station Models, and it's marked as optional, but I want to kind of walk you through how this works for some more information on them. So usually we see these on weather maps, and they're used to convey a lot of weather information in a very small amount of space. So this black dot in the middle is this station, so it's a location. Usually, I think our local weather station, we have Grand Rapids, we've got Detroit, we've got Chicago, are our National Weather Service offices. So that would be representative on a map of this dot, and it would be shrunk down to size to fit on the map. So this looks like a lot of random information for you, but really it's meaningful once you get to know the weather a little bit more. So this upper left corner here, the 62, that's representative of the temperature in degrees Fahrenheit. So we don't include units on here because it would be too much information on such a small space. So in the United States, this is in Fahrenheit, and it's just an accepted thing. So 62 degrees Fahrenheit in this location. This lower left number, 61, this is the dew point temperature, which is the point at which the air becomes completely saturated with moisture. It can't hold any more water vapor as it's cooling. So we're only 1 degree different here. So I would expect it to be cloudy, almost rainy here. So 61 degrees Fahrenheit is the dew point temperature. This 2 1/4 number is representative of visibility. So in this location, we can see 2 1/4 miles here in the United States. The 3 dots here is a weather symbol. So this is indicating what type of weather is happening at this place. The 3 dots is indicative of rain. So it's raining in this spot, and this filled in circle here where the dot is, this is filled in, this is 100% cloudy. So it's cloudy, it's rainy, you can only see 2 1/4 miles. It makes sense because our dew point temperature and our air temperature are only 1 degree Fahrenheit different from one another. So all of this makes sense to me as it should be happening. So if it was a clear day here, I wouldn't color in any of the circle. It would be completely empty. If there were 25% clouds outside, I would fill in 25% of the circle, and so on and so forth. This stick that kind of comes out the left side, this is the direction of the wind and oriented in the way that it's coming from. So think of it like a bow and arrow. When you pull the bow back, and you let go and the arrow flies and it hits the target, the arrow is sticking out in the direction that the arrow came from. In the same way, the stick sticks out on the station model in the direction that the air comes from. So in this case, on a map view, the winds are out of the west. So north, south, east, and west. The barbs on the end here indicate the wind speed. So the long barbs mean that the wind is at about 10 knots, which is a wind speed that's equal to about 1.15 miles per hour. So long barbs are 10 knots, short ones are 5, and you can add them and stack them to get to the correct wind speed. So here the wind is at 10 plus 5, 15 knots. Which is a little bit more than 15 miles per hour. So if I had 25, I would do 2 longs and then a short. If I had 30, I would just do 3 longs. If I have no wind, I would not have a directional wind stick. I would just have a circle around the station indicating calm weather, 0 wind. And then the last thing that I want to point out on here, so this is, first off, this is a pressure tendency. It shows whether the air pressure is rising or falling. I'm not interested in that for the purpose of this class, but I think it's worth noting up here in the upper right, this 942, that's a code for the air pressure, indicating what the air pressure is. So in this class, and as is the standard in most weather systems, it's common to use the units of millibars. So that's a bar, but it's metric. So milli, just like a millimeter, or milliliter. This is a millibar. So standard air pressure on Earth ranges from about 960 millibars up to about 1,059 millibars. And that's the range that we'll use for this class to keep it nice and easy. And if you look on your station model sheet that is on Moodle, that I'm bringing into the screen now, down here you can see how we break this up, because when we take it with a tenths place decimal and the units, it just becomes too much stuff to include on the station model. So what I do, if it's in the 900s range in millibars, so it's from 960 all the way up to 999.9 millibars, there's some common items in all of these numbers. First off, we can get rid of the units as we have everything else for the station model. We can drop the decimal place, or the decimal point, sorry, and we can also drop the first 9, because every number between 960 and 999 starts with the digit 9. So what if I get rid of those 3 items, that leaves me a code of 600 to 699. And basically what that is, that's the tens place, the ones place, and the tenths place. And that gives me my code for the station model. Likewise, on the other side of 999, we're ranging from 1000.0 millibars all the way up to 1059.9 millibars. Everything in that range starts with 10. It has a decimal point in it, and it has units of millibars. So just like on the 900 side, I can get rid of the leading 1 and 0, I can get rid of the decimal point, and I can get rid of the units. And that leaves me with a range, code-wise, of 000 to 599. So you can see, as soon as I add 1 onto this 599, it becomes 600, and I'm down here. So there's no overlapping numbers. So if we go back to our station model here, it's 942. So if I'm working backwards, this 942, the first number is a 9, and that falls over here in this 900s section. So if the station model starts with a 0, 1, 2, 3, 4, or 5, to work backwards, we're going to put that leading 10 back in, add the decimal and the units. If it starts with a 6, 7, 8, or 9, I put that leading 9 in front, add the units and the decimal. So 942, as that's read, 942, falls over here. So what that would actually be in millibars is 994.2 millibars. Because what I have here, just as I said before, is the tens place, the ones place, and the tenths place. So that should help you figure out what's going on here. And I'm hoping that with these, this document here that I made for you, and this little explanation, that you understand a little bit about the weather in better detail. And if you see a weather map for your Watch the Weather forum, you'll be able to understand a little bit more about what's going on in greater depth. So that's all I've got for you right now, and I will probably be back on another video later in the semester.